Henry Muhlenberg House, located in Trapp, Pennsylvania, is an historic structure that predates the Revolutionary War. Painstakingly restored and now open to the public, the house provides fascinating insights into 18th century American home building techniques. As we'll see in this story, it also incorporates a very modern approach to heating and cooling. Jon Costanza of Sunpower Builders was the general contractor for the renovation. Well, Jon, we've really stepped back in time here.
We have. We're back at 1754. This is, or was, the home of Henry Melchior Muhlenberg, and when we restored this building, that was the idea. If Henry came home today, he would feel like he was in his old house. And this house has many interesting features that we would find in today's green building projects. At that time, sustainability was really more defined as survivability, and anything that could be done, to make your life a little more simple and easy was employed. Building materials came very locally. They were also very specifically used, where they would use a particular wood like yellow pine for the floor that was extremely durable. And longevity is also one of the things that you want to consider in sustainable building and design. You'll see that most of the windows in this building are focused on the south side, and the building is oriented so the south side is capturing a lot of that good sun. We've got windows, again, that have splayed jambs that are allowing probably 20 to 30% more light deeper into the building just by a simple detail like that. And for people that had to light candles at 5 o'clock at night, that made a big deal to them. When we look at the outside of the building, you'll see that there's a pent roof on the front and large overhangs that would prevent that sun from penetrating deep into the building in summertime and making it hot and uncomfortable. This is one of the first examples of insulation that I know. Also, this building, under these floorboards, there is a material that's called paling, and it was just simply a mixture of straw and mud that was packed in to keep airflow from coming up from the cooler basement. The walls are massive in their stone and retain both heat and coolth. And when we look at the fireplace, we'll see that there's almost 30 tons of stone in this massive fireplace and chimney. One of the unique features is that this fireplace sticks far into the room, so that when that mass was heated, it was brought more into the living spaces. And you'll see that there are a number of large fireplaces like this. The cooking fireplace is on the north side, so in the summertime, you didn't suffer as much with the heat of the kitchen because you were on the cooler side of the house.
Jon, I noticed these two holes here in the side of the firebox. So what is that all about?
Well, that was another interesting piece of sustainable technology. They didn't have to keep another fireplace going because by having this hole in the wall, they could shovel coals straight through that hole into a 5-plate stove that's on the other side of the wall. You want to see it?
Yes, I do.
Okay. And Rob, here's the stove. As a cast stove, this was novel at that time. You can see there's no ventilation or chimney, so it drew its air and let its smoke go up the fireplace, and they were able to feed it from the other side. Again, Henry was ahead of his time in trying things that would increase energy efficiency in this building.
Well, I know we're in a museum now, and we're not heating the museum with these various systems. So what's being used to heat and cool this place now?
I can show you.
Great, let's do that. Oh, well, it looks like we have some sort of geothermal system here.
We do, Rob. This is a self-contained unit with both a compressor and air handler in here. It's what is called a open loop system, or in terms that a contractor may use, it would be called a pump and dump. There are also closed loop systems and earth coupled systems that we could talk about. But in particular, this system draws water from one well, runs it into this piece of equipment where it runs through a normal compressor like any heat pump that that people are familiar with running outside the house would do. It extracts as many BTUs as it can from that water. So we generally figure that for every 1 BTU of energy that goes into a geothermal heat pump, we will extract 3 BTUs of energy in form of heating or cooling usage. And then it returns the water through another line to a secondary well where it gets returned to the aquifer. The temperature difference of the incoming water to the outgoing water may only be 4 to 5 degrees, so it really doesn't have any negative impact when it feeds the aquifer.
Well, thanks. You've made a complicated system rather easy to understand.
That's a pretty neat old building, huh?
Absolutely. So what are the chief advantages of a geothermal system, and how do they help us save energy?
Well, a geothermal system is going to save you almost 60% as compared to a conventional heat pump. For every 1 BTU of energy that's required to operate this system, it will give you 3 BTUs of energy in exchange. And that's because it has a reliable, constant, steady source of energy to draw that from.
Are these systems appropriate for any location?
Well, one of the beauties of geothermal is that it is appropriate in many different climates. Whereas conventional heat pumps will struggle when the outdoor air temperature gets very cold, a geothermal system, because it has a constant input temperature, can still operate efficiently at very cold outdoor air temperatures. But the geothermal heat pump was very appropriate for this project because Henry Muhlenberg was an expert in energy efficiency. He lived energy efficiently, and we know that he would appreciate having this in his house if he came back today.